And if we take a look at the domain of a rational expression, we've already seen that you cannot divide by 0. So you can't divide by 0. So that means that the domain is all real numbers except the denominator can't equal 0. That goes along with your worksheet that the after test review that you've been working on, is that we know the denominator can't be 0. Here's your example. I don't care what the numerator is. The numerator can be anything it wants to be. It says find the domain of the function. Here's your denominator. The first thing I always say to myself is this: the denominator can't be 0. And what is the denominator? The denominator is x squared minus x minus 42. It can't be 0. That gives me the equation to solve. Factor, that's x minus 7, x plus 6, can't be 0. And it comes down to x can't be 7, x can't be negative 6. Now, this is what your book does, and which I don't want you to worry about, because I think it's stupid. Your book puts in step 2, it says put it in set builder notation. Who cares? As far as I'm concerned, the answer is x can't be 6, x can't be 7. You're wasting a lot of effort otherwise. But some books get into the set stuff pretty heavily. On a number line, this is what it would look like. There would be, it does not include, and it doesn't look like either, yeah, I didn't pick this up or it didn't pick this up. Negative 6 does not include positive 7. Everything is shaded except those two things. So if you write it, which again I find is useless, in interval notation, it would be minus infinity to negative 6 not including, union, that means or, negative 6 to 7 not including, or 7 to infinity not including. Just say x can't be negative 6, x can't be 7. I hate wasted effort. I have other things I can do with my life. I guess I now have that on video. That's probably not a good idea. Now I can't basically say, I never said anything like that. I didn't say it was stupid. Well, I'm sorry, it is. Sometimes I just can't help myself. It's stupid. But I want to put it in here because that's what your book does. Find the domain. I look at this and I know the denominator can't be 0. That says that x minus 2 can't be 0, or x can't be 2. Now, in this class, if you just write x can't be 2, I'd accept that answer. Don't bother with, as long as if you take a look at set builder notation basically has everything. If you look at set builder notation in the back of the book and it says x can't be negative 6, x can't be 7, you say, well, that's the answer I got. You don't have to have the rest of the stuff in there. X can't be 2. Now, my college algebras, by the time we're finished with chapter 3, they're going to do this. That means all real numbers except for negative 2, or except for 2. Now, your book puts all this stuff on the number line. It does not include 2, but it includes everything except 2. So if I want to write it in interval notation, which again I think is kind of useless, minus infinity to 2, not including 2, to infinity. So that's in the forms that, as far as I'm concerned, if you just give me x can't be 2, I would be thrilled. You want to put it in the other ways, that's fine too. I don't care. As long as it's correct. Find the domain. Remember the denominator can't be 0. X squared plus 2x minus 3. Don't care about the numerator, just that guy. Can't be 0. X plus 3, x minus 1, can't be 0. So this is going to tell me that x can't be negative 3, x can't be 1. So now we're in the 5, 8, right? So x can't be negative 3, x can't be 1. That is a good enough answer for me. And in college algebra, we add this, and I don't care whether or not you do in this class. I don't even care if they do that in college algebra. So what do we know? X can't be negative 3, x can't be 1, and everything else is shaded. So in interval notation, minus infinity to negative 3, or negative 3 to positive 1, or 1 to infinity.